Hi everybody, my name is Brendan. I think you probably figured that out because you're here and it says it up there. There's various contact things up on my slide. I can mention those later if you want to talk to me. Let's see what to talk about. I don't work at Microsoft. I am just one of those independent people that happens to like the language. And I love talking about it. So without further ado, let's get started on Not Your Mother or Father's C#. While we jump in, I have a couple of disclaimers I want to get through first. So my father was never a C# developer. I will admit that. He's a retired software developer. He used PHP at the end of his career. My mother's also not a programmer at any kind, so she never used C# either. You're probably now wondering if everything in this talk is going to be a lie. The answer is probably. I don't know, we'll see. I might have something true in here, we'll get to it. And some of you are now probably wondering if my first name is even Brendan, because I've lied about everything else so far, and the answer to that is no. So, so now that we've gotten everything started off correctly, I'm glad that you realize that this talk is going to be fun. So, I'm going to start off with some other things that are not true. So, this is going to have some very outdated stuff here, because we're going to go back to our, parents' C# here. Maybe grandparents for some of you. I don't know. Are there people that young in the audience? I don't know. So a bunch of people probably think, at least used to, that C# was one of those Microsoft languages where you're going to be running Visual Studio, and you had to run Visual Studio or it wasn't going to work very well. And for a while, even after Visual Studio Code supported it, this was still somewhat true because the tooling was much better on Visual Studio than it was on VS Code, but this is no longer the case. Now you can pretty much do everything in VS Code nicely that you did in C# before in Visual Studio. You no longer need Visual Studio in Windows, and you can be a C# developer. Congratulations, no weird mono installations or anything like that. You'll also get the people that will sit there and say like, oh yeah, that's for Windows development. And no, it is not for Windows development. You can make games, you can do all kinds of things, you can run software on lots of different systems, on the web, etc., etc. It's actually quite a nice environment now, especially with the modern .NET instead of the old .NET framework stuff. And then we get into what the language looks like. And it looks a lot like Java, has similar origins to Java, and is very similar to Java, but I can assure you that as of like 15 years ago, it became very much not like Java. Then we've also got the complaint that C# is one of those big curly brace languages with tons and tons of curly braces, but if you've been watching the language recently, and I'm going to point some of these out, but not as many as I used to, they have made a lot of ways for us to get rid of all of those extra curly braces so you don't end up with 8 curly braces ending out a section of your code. And then the biggest one that I really want to fight against is that C# is some old dead language from 25 years ago-ish that, people used to use, and now we've moved on to other things, and that's just absurd. And then you also get the people that are thinking, well, it does still get used, but only by enterprise corporations for these big monolithic apps, and never for anything, lighter weight like what I'm building. And obviously those are all, absolutely crazy, and we should kind of just ignore all those comments because we know that those are not true. At least I'm hoping most people in this room do. So I want to start off by addressing one of those things that we just mentioned, which is the curly braces and indentation. So I'm sure everyone who used C# even a little bit in the past has seen code that ended up looking like this at some point where someone really needed to call methods or something because we got out of control with our scope and ended up with, I don't even know how many that is, like seven or 8 curly braces there closing out that little method there. And I can actually do now here's where I'm going to lie to you, exact same code with something more like this, which, yes, I've only removed like 3 or 4 curly braces, but you can chop out a whole bunch, and even though still bad and we should probably separate some of this out and refactor, we've at least removed the curly braces so you can kind of tell what's going on. Now, I've sort of addressed that obviously the language has changed, it looks different than it did before. Hopefully that kind of illustrates that, yeah, they've made some adjustments along the way. Let's talk about some of the stuff that we really were missing back in the days of like our parents' C#. because it really was missing some basics, and there were lots of valid complaints. So in the early days of C#, in fact, when I started working with it, there were a whole bunch of complaints. For example, it did not have generic types even when I first started using the language. It actually has a fantastic one now. It didn't have lambda functions, which was a huge complaint to me because I had come from a language that had those, and then I had to use delegates in C# and was quite annoyed. But we now have really good, strongly typed function variables with all kinds of customizations that are regularly getting adjustments, and we'll talk about some of those. So it's really nice to just have plenty of ways of doing that kind of stuff. The tuple that was in the language was a joke. I hope no one is still using the old tuple, and they actually have, and I will switch to tuple at some point in this for those that say it that way. I try to do both. But about 6 years ago, I think it was something like that, we finally got our first real tuples in the language. They added a new value tuple, and they're regularly improving things, which is the part where it's not a dead language anymore that I mentioned. And then some of the other stuff that you've probably seen in other languages. Obviously now, hopefully most people are aware that C# has async and await, and it didn't used to, obviously, but it does now, and we've had it for about a decade now, and interestingly, it uses similar syntax in a bunch of other languages because they all kind of got the implementation from the same places, and some of the teams that worked on them had some of the same people. So if you've noticed that a lot of languages have the same looking implementation, there are reasons for that. So now that I've established myself as a young person who clearly only works on C#, I can blend in with this crowd because I'm only using the modern stuff. Definitely not outdated at all. So let's talk about some of the recent new features. So I should mention that this talk that I give here, I really like doing this talk. It's a lot of fun, and I specifically hate the what's new talk. So this will have the content of a what's new talk, but I hate that one because of the fact that the what's new talk frequently only shows you things that are unavailable to you now. So I have a quick question. I can't really see hands because they like blind us with lights up here. But are people in here generally C# or .NET developers, by show of hands? But sometimes you use it? Okay, so mostly, who, out of curiosity, are people here using .NET 8? If you know, or is anybody here using .NET 9? The non-long-term support? Okay, so fewer people. Okay, so for clarity, before we get in too far, on these slides that we're going to get into here, I will mention C# version numbers on them for translation to you, to help you out. If you are one of the .NET 9 people, you are version 13 of C#. If you are .NET 8, you are version 12. If a number is under those, which we will have slides about that stuff, specifically because I need to talk about some features, especially if they then change the feature, to make sure people know about what the feature is that got changed. I will mention version numbers. In fact, we're going to start way back in the day as we get into this because there's something that I'm going to use later and I want to make sure people know it exists so they don't find it weird. So let's get to a recent feature of C# in C# 6. Yes, we're on C# 13. We're going to talk about C# 6. So in C# 6, they added something very, very, very useful I'm sure you're all using. It's called static usings. It allows you to declare a static type that you just want to have available in scope, which was really a funny feature. And the reason I like it so much is you'll notice if you look at this code, it has obviously system.console has been put in scope, so I can just call those methods as if they were in scope at this time without saying console dot. And you might go, who's using so much static code that they would want to call through a method without giving the name of the class? And there's a short answer. People that are presenting demos in front of an audience, because we want to keep it short enough to fit on a slide. So thank you, Microsoft, for building that for us, and I will continue using this feature that was clearly designed for me and not for you. But we had to talk about it. Now we're going to talk about one of my favorite features. I spent years yelling at Microsoft about wanting this feature, so this is why we're starting here. We wanted primary constructors, a whole bunch of us. I love primary constructors. They are fantastic. They're a great addition to a language. We had been asking for them for years, and they were expected in the language repeatedly. In fact, in my slides, in many, many times doing talks similar to this one, I would be able to put in previews of future things that we wanted to have as primary constructors. And then do you know what we got first? Something else. But we eventually got primary constructors. And primary constructors look a little bit like this. So when you look at this, this is declaring a class, but at the end of the class declaration, so it has public read-only class rectangle, it then goes into parentheses and defines two parameters, a length and a width. Now, just having those parentheses and parameters there has defined the constructor for this type. So down there is not, inside that curly braces is not, that's not a method. This is a class, so that's defining a property in there. And when we do that, you'll notice that the area property immediately has access to length and width. So in addition to creating a constructor, because remember this feature is called primary constructors, which is a little bit weird, it has added a length and a width on that class automatically. Now someone in here is probably sitting here saying, wait a minute, Brendan, isn't that just a record type? And you'll remember that I said they'd been offering us to build primary constructors for a while and they didn't do it, and they gave us something else instead. Let's talk about record types. So thank you, person in the audience who was on the screen and wasn't really in the audience. See, lying again. So record types in C# 9. So we're going back. So remember, we just did a C# 12, and we're now jumping back to C# 9 when we actually got our first instance of this. This is a record type. Now, I'm going to explain more about record types than I did about primary constructors, because record types use primary constructors, so I can talk about this weird type, because I think all of you know how classes work in C#. So a record gets declared in pretty much the same way that we just saw. You declare your type, we say public record, give it a name, and then just immediately go in as if it's a constructor. Now, you'll notice that it doesn't really define anything here that is a single line, so we didn't even have the curly braces and get into other properties. So in this case, this is just a value object. It has no methods, no properties, no anything in it. But there's a lot of fun things we can do with record types, which is why I want to bring them up. So if you've done much work with C#, you are aware that if you have two variables that are class variables and they're pointed at two separate objects, you've created two instances of them, you've called new twice. That's what the blue section is up there. They have identical values. If you do equality on them and you didn't write your own custom equality comparer, it says, hey, that's a reference comparison, compares the pointer addresses and says, hey, those are not the same thing. If you take two variables, only calling new once, so you've only got one set of data, they will point at the same data and, hey, that's the same pointer, so they are equal. If, however, instead of using classes, you are using records, your defaults work a little bit differently. So when you're using references, when you're using value types, you're actually, records are a value type, and thus they're not just pointers to that data that are going to do a referential comparison. They actually have an equality comparison that compares the values within them. So in this case, I can take two identically made but separate variables, objects, compare them, and as long as all the properties are the same, it will give us equality. So it's kind of convenient. Okay, so I talked a little bit, let's look a little bit further at what we can do with these. So with a record type, we can just declare a basic constructor like this. So that first record just defines that we're going to have a title, session time, and a speaker name on there. And then we also have a second one, and that one doesn't have the constructor at all. And you might be going, wait, does it still have it? It's like, yes, it still does, because it still gets created the same way. So either of these declarations will get you effectively the same object, two instances, same way of declaring basically the same thing. The other nice feature that comes with a record type, which I'm a big fan of, is that it automatically has a default for toString that isn't as awful as every other toString you've ever had in a .NET object. Has anybody ever toStringed an object in .NET? Yeah, what'd you get back? You got back the type, and that's it. And you're like, well, that was useful. No, that wasn't useful at all. You'd give me nothing. Whereas this automatically has a default that just prints out the values. So that's what that bottom line is there, is what the value is that you would get printed for that. Okay. One of the other nice things that you can do with record types that you can't do with a regular class is you can create new instances from existing objects. So this can be useful if you are, say, in a testing scenario or something like that, or you get an object from somewhere and you need to make a modification to it, but you don't want to lose the original one. So you don't really want to change it. You just want to make a new instance that's slightly different. And so someone here is thinking, like, what do you do with it? And my answer to that is yes, you with it. Now everyone's confused. No, not what, with. So we're going to use the with feature here after my terrible, terrible joke. And what's great about with is that we can make a new instance of a value type. That's what we're doing on that first one. And then we can take that same instance and use the with keyword and just specify the properties we want to change. And so it will leave the other properties alone and give us a new instance of that type with the values changed. And you'll notice then we do that again in the next line. So it's super, super useful if you're like, yeah, I need the same thing, but I just want to make a quick update. This works really well with test data or something like that. If you're like, yeah, I need two instances, one that has this value and one has that value, you create one and then just with the next one, as long as your code obviously accepted this value type for it. So I really like record types, and the stuff that you do with record types is very similar to primary constructors. Some of the freebies that you get out of that work the same way. So primary constructors, nice. Record types, super nice because they get the things like withing, which the primary constructors don't get you. If you're wondering where would I use these, if you've ever had to do any kind of DTOs or anything like that, I know a lot of people that use them for that, or just other value objects that you have throughout your system, record types are actually pretty useful for those types of circumstances. Okay. Next thing I want to talk about, again, because I'm going to be using it later, and this is one of my favorite features ever. I absolutely love this, and I am going to upset some people around here. I hate var. Now everyone's upset. Yeah, I know. I hate var. And the reason why I hate var is because everybody used it. Always. And the tooling used it always and encouraged it always. And then you lost the type, and everybody says, but Brendan, you can just put your cursor over that. I don't want to grab my mouse and put my cursor over something to see its type. I want to just see its type, if it's simple. And then everybody would be like, well, what about if it's some weird, crazy Lambda one? I'm like, yeah, use var for that. You don't have to use it for everything else. Well, now I actually have a way of telling you why you shouldn't. Let me show you constructor inferences. So we can now infer your constructor. They have implicit constructors. So this, and it bugs me, everybody using all their AI tooling, it never recommends this, which just irritates me like crazy. This is 100% the best way of doing this now. Obviously, if your type is wild and is like 20 characters long because you have some weird lambda result, sure, yes, use var. But if you don't have that, this lets you actually define your type on the line. So you'll notice that these two lines do the same thing. They're just creating objects. And how are they doing it? They specify the type, the variable name, and then you say equal new. They don't have to repeat the type again because it knows what type you're putting in there. You're putting in the one that gets assigned there. Now, I admit, yes, if you wanted to return this into an interface, you'd have to specify that. But if you were using var, you had to do that anyway. So this is actually going to get used later on in the code because it's really nice because let's say you're passing a parameter to a method. You do not have to specify the type because the method parameter said what type it needs. You can just call new and start passing in the parameters. That one you might get yelled at about, but, but you don't technically need it. So one that I want to mention, because I don't see people use it very often in code, again, this one's a little bit old, and it only setters is a feature out of C# 9, and it's basically in our properties. You can actually specify one as init instead of doing a set. So, and that just means that it has to be set during initialization. So it does not have to be the constructor either. It can be in object initialization like this. So you'll notice that I've got the birth name Brendan because we're lying again. See, people still think my name's Brendan. It's great. All right. One other thing that's useful I find in both testing as well as super useful if you're doing demos and you're presenting to an audience is the params array. Has anybody here actually used a params array ever? Occasionally? Okay. So I will quickly show you what that looks like in this discussion about params collections. So a params array is this. Essentially, you can add the params keyword in your method before you give the array, so it's params int array numbers. And what this says is I can accept an array, or you can just start listing integers and it will automatically, you know, take those and put them in an array before passing them to my method. So it will do that behind the scenes for me. So the result of those two lines down there, you're either passing an array or you're just passing the same data, will functionally be the same in your code. Now we have something called a params collection instead of a params array. And for this, we can use basically the vast majority of collection types in C# can now be used with params. So if you want to be able to take some set of data, you don't know how many you're going to type it in. It's really useful for tests, by the way, especially if you're just doing a method and you're like, I need a set of test data. I'm just going to type in 4 results here, 5 results here, 6 results here, whatever it is you need. And you don't have to worry about adding or removing parameters to whatever method you're using to help you. This is how you can do it. So you'll notice down in the bottom, I just call something 1, 2, 3. That's just going to give it a span with 1, 2, 3 in it. And it doesn't just work with spans. It works with iRead-only spans, IEnumerables, collections, iLists, like anything you can think of. It probably has a version. I think the requirement, you'll notice I have an asterisk on there. The asterisk is that the enumerables, I believe, need to have an add method. So you can be an IEnumerable as long as you have add. And I think it checks for that at compile time. I forget exactly where it does that one, but that, again, C# 13, so remember that's only the .NET 9 people. There's some other weird tricks you can do as well. But I want to get jumping ahead. So I'm going to mention string interpolation, and someone here is going to yell at me. They're going to be like, Brendan, string interpolation's old. I know. String interpolation came out in C# 6. But you know what? I'm old. I mean, young, old, I don't know. I'm something. And yeah, exactly, I'm old. Who am I kidding? So back in the day, we used to get these arguments, these big fights. There'd be some person that would say, no, you need to do it with string concatenation. No, you need to use string format. And then I was really happy because I just jumped in and I was like, string interpolation! This is clearly the answer that we should all be using. I know I'm a nerd. And string interpolation is this, it's too big a word that basically just means insert into. So when you interpolate the strings, you're just going to insert a variable into the other one. We have this in most languages now. It was really nice when it got added to pretty much all of them. You just use $sign at the beginning of your string and says, hey, this is an interpolated string, so any curly braces I use are going to let me write code in there, and it's going to insert in whatever the result is of that, and that's how that works up there. And you're wondering why I'm talking about something from C# 6. And the reason is because I want to talk about something from C# 7. And in C# 7, we added the ability for these to be constants. So you can interpolate the string and then store the value in a constant. So that came out just a couple of versions, like 3 versions ago, in C# 10, which is very nice. Now someone in the audience is saying, Brendan, 3 versions ago? Why are you still talking about this? Well, because I want to talk to you about something that came out in C# 11. So not only can you put them in constants, but we now get to talk about, well, first we're going to mention verbatim strings, which are really old, and I hate these. If you've ever seen a string that starts with an @ sign, then it lets you put new lines and break it up. So you'll notice I've got new lines in this string, and it's all valid here, but then the problem is as soon as I want to put in a quote, because of the way the verbatim string works, which, has anyone ever put a quote inside of a string? Yeah, it's awful. And when you use a verbatim string, you know what they make you do? Put in double quotes. So this thing's just loaded with double quotes and looks absolutely terrible and is impossible to use. I don't like it. So in C# 11, they added something called raw string literals. And that looks like this. So instead of having an @ sign, you actually just put in 3 double quotes at the beginning, and that says, hey, I'm going to do a raw string literal, which I'm then going to close with triple quotes as well. And you are now allowed to use quotes in there without any problem. So you can get new lines, you can get quotes. It's really nice when you have like some big chunk of text that you need to hard code in somewhere, and you're just like, yep, this needs to be here. And you can just toss it in like this, so it's now suddenly not terrible. And the cool part is, you can interpolate them. So if you toss in some dollar signs at the beginning and use the triple thing, you can then just get curly braces to be able to throw in the values there. So interpolated raw string literals are actually pretty darn useful, though only in the circumstance where you run into needing them. Try to avoid it. Obviously, having raw strings hard-coded into your code is not the best thing, but when it happens, this will be like, you're going to love it. Okay. Something else that comes up a million times that everybody's probably run into. Who here likes locking? No one? No, oh, okay. Well, .NET 9, and obviously then we're going to get it with a long-term version, .NET 10 later because it will be included, added a new locking type. So, and now in my talk, this is specifically a C# talk, so I try very hard to avoid things that are .NET and focus on things that are C#, which is a tough distinction, and in this case, they adjusted both the language and the framework for it, so I will talk about it, because they added support for the type. They added a new lock type in .NET, so C# 13 added support for it. So before adding these, this is what we did. I mean, roughly speaking, we'd create some object, and then in our code, we would lock, using the lock keyword on that object. They're going to move us away from that because some of the challenges here is that you had to handle this in certain ways. There's weird stuff you had to do, and they're actually going to go to iDisposable for it. So the new lock type works like this. You make a new lock, and inside of your code where you want to use it, where you want to make sure that you're the only thing running, you want to essentially lock on that object like we did before, you're now going to enter the scope of that lock. And so that will then return back an iDisposable object that you're going to use and you're using. And then that's what essentially allows you to say, I'm the only thing in here, I'm running sequentially again. Does that make sense? Super, super nice. I love that they changed this. It should make a lot of things less confusing. And the nice part is because they're using iDisposable, when you leave that using, it's going to release that and everything will be fine. All right. Next thing that I want to talk about is collection expressions, which are kind of fun. They got picked up in a couple of other languages as well, and some have had them for a while longer than we have. Collection expressions let us do a little bit more with our collection types. So in this first part here, I declare an array that has 1, 2, and 3. And yes, I am using the array initialization syntax, which I realize I've got my slides out of order, so I'm going to need to adjust that. And the cool thing about that syntax is I can just create an array. And I don't have to worry about curly braces or anything like that. Remember I said we were getting rid of curly braces? Then the second one creates another array. And then in that third line, I tell it to essentially spread out the values. So that's what that ... and then followed by the name of that array. I'm basically saying, hey, take that first one, spread out the values right there. Take that second one, spread out the values as well, and then include more values. So if you have two arrays and you want to put them together and add additional inline values, no longer do you have to like concatenate the two arrays together and add, because they gave you fancy syntax for it, which up to you whether you like the fancy syntax better. A lot of it comes down to preference, but it will make that bottom array there, that 1, 2, 3, 4, 5, 6, 7, 8, 9. I know it's a random sequence of numbers. Okay, one thing I want to talk about is pattern matching, which I have fun with. I like it. There are some use cases for it. I know some people get a little complaining because they go, what about polymorphism? We'll talk about that in a second. So pattern matching, part of the reason why I want to talk about this, even though it is old, it is from C# 7, but then it got adjusted in C# 7.1, and 8, and 9, and 10, and 11, and hey, 11's only 2 versions back. So we're going to talk about it. So whenever I talk to people about pattern matching, there's always some confusion because people don't really know what pattern matching is. And since we're a little bit disconnected from the audience, I'm going to help you all through this a little bit. So I've got this picture of this little thing. You take shaped little pieces. This is a little kid's toy, and you try to put them through the holes in that, and they go into a little bucket. It's kind of like, square peg, square hole, round peg, round hole kind of thing. And someone's going like, well, what, you might wonder, like, what does this do? And this is the way that I like to explain pattern matching. If you can send your object through that hole, there are 2 things that we get. we know the shape of the object that went through the hole, in theory, because it's supposed to be the shape, you know, to go through. Obviously, I know some people like shoving the wrong ones in the wrong holes, but if you did that correctly, normally, like a regular person, you know the shape, and you have it. It is now in your bucket. So this is how pattern matching works. If the pattern matches, you know that it is the type or pattern or shape, whatever it is you said it was, you know it is that, and you have it in the form you asked for. So whether it's your bucket or a variable, you have it. And what do I mean by that? So this is the original code that we might have written to check and see if an object is of a specific type. We would say safely cast it to that type. So we're going to say take our shape, cast it as a rectangle, and check to see if it's null. So this was a safe cast. If it wasn't that type, it would be null, and we can use it. But now we have is. And the wonderful thing about is that we get the type at the end. So when you take a look at this code, it says if the shape is a rectangle, REC, then we can immediately start using it. So if you look at that code after the is, and you just look at rectangle REC, you'll see that that is a variable declaration in C#, to the right of the is. And because it's just a variable declaration, that's literally all it is. So you now have that type and can use it. I could have run that as anything. I could have said if it's an object, and then I'd have an object version of it. So it is a cast and creation of a new variable at that point. So when we take a look at some other code that does the same kind of thing, this is going to the beginning, there are a few ways that we can do pattern matching. We can pattern match against constants. Null is a constant, so that is a pattern that we can match against. We can also pattern match against individual specific constant values, depending on our type. We can pattern match against types like rectangle or triangle. Starting in C#8, we could do property patterns. So you could literally take the properties, declare some property objects right in line and say, hey, if it has a state value and a name value, is this session in Ohio at Star Trek? Hey, cool. We know that this one is one of the ones here at this event. So you can pattern match and say, hey, you're here. In C#10, we added in nested property patterns. So now if you have to get, you want to check, oh, not that, we use an address value instead of just having the location right on it now, so you need to check down in the nested thing, you can pattern match on that as well and get only the objects that are, with an address.state of Ohio. So you don't have to do the extra curly braces. Remember how I said we're getting rid of curly braces? We're getting rid of curly braces. And then in C#11, they added something really cool called list patterns. And I'm going to have two sets for you. These ones are all true. So we have that initial list at the top, and we can do some fun stuff with it. Not only can we check the full match, which is what that first one is, we can say, hey, if, our stuff is this, we can do that. And then in the lower ones, we can do the two dots we used previously to spread, but here it's going to sit as a wildcard. So we can say, hey, this, and then we can also use ors and things like that to say, hey, if it's A or B, then we'll allow it. So we get little bits of logic and wildcard values as well. So super, super useful. And we get the same thing down here with these ones are false, and these ones just don't match the set. And then that's why it is able to work. Okay. Let's then also talk about the span of character patterns. So we can now, in addition to doing the list patterns, we can also check the values of things like strings like this. So in this case, I can say if name is Brendan, checked on a span of characters, I can just compare with that and it works fine. And then I can also say things like, hey, I can check if it starts with B by just doing a pattern match on it, which I know there's other ways of doing this. I'm just, as an example, you can do these kinds of comparisons. Remember the complexity from the previous one, you could check beginning and end without having to do like first and last letter and comparing them. You can do a pattern match with it by doing that little dot dot operator, which is essentially like a wildcard. We're saying B is the first letter, and then there's some other sequence after that. We could have done a first and a last if we wanted, and then we could put all the Brandons, Brendans, Bradens, Bryans, etc. together by putting all the B's, N's, and N's, for example. Okay, C#13 added something else that's kind of weird. I've run into this before, but I don't know how many other people have, where a specific overload of a method, I want to have priority, and C# previously didn't have a way to do this if it evaluated them to be of equal worth to your, like, essentially, You could get it to pick certain ones by being more specific, but if there were two options that were equally specific and both matched, you didn't have a way to say, hey, prefer this one over that one. So we now actually have overload priority in C# 13. So let's imagine we have this code right here where we have a class heckler and they have shout methods, one that takes a string and one that takes a read-only span of characters for performance reasons, of course. And then we have down at the bottom a variable example that is supposed to shout something. Boring. Thank you. And now we'll continue on. So if we wanted to specify that we wanted to do that with the read-only span of characters instead of the string, we can add in overload resolution priority, which is such a short name, it just rolls off the tongue. Thank you, Microsoft, every time. And we specify the value that we want in there. So your default value is now 2. If you don't specify a priority, essentially every method has 2, or has 0. And if you want to go above this, you can add positive numbers, and that's going to give you a higher priority. You're going to be selected first. If you want to take a method and say, hey, I don't want this used, you can give it negative numbers. Okay, so you can do negative numbers or positive numbers depending on whether you want to encourage or discourage that method from being selected by C#. Well, I should say .NET. .NET's doing the selection. C# is how we're declaring that. Anyway, you get the point. So this, for example, would be the way of negating the string. So if we just said, it's not really that we want to encourage span, it's that we want to discourage string, you can do this way. Okay. C# 11 added something called the required modifier, which I actually kind of like, although you can get yourself into a little bit of a mess here. Let's talk really quickly about it. So in C# 11, we added the ability to define a property as required. So if you'll look, our ID and our name are both required here. That means that in our, we are not required to do it in the constructor. It can be done in initialization. So you can use object initialization, which is the curly braces. I know we're killing them, but we do use them sometimes. And you can tell that because I've got two constructors here. One that takes them in as parameters and one that does not. And the one that does not, obviously, how would you call that if they're required? And the answer is you use the object initializer with it and fill in those values. And it does compile time checking for these. So it's going to make sure you did it. The compiler is going to get in your face and yell at you and not let you compile if you did not set that. However, that little attribute, that sets required members, if you use that somewhere, it will disable the check. So I just want to give you this warning that you can do that if for some reason it thinks you haven't set it and you have, you can get around that. Now this is super useful to just make sure that your objects are always set up the way you want without having to go to full you know, not accepting nulls. So we're not going into the null context here, but you can do that. Keep in mind that you can set the value to null explicitly if it is a nullable object. Also, so it's not protecting you from nulls, it's just making sure you set it, just for clarity. We also finally got the file access modifier for modifier types. So in addition to private, protected, internal, public, etc., we also have file. So within a file, this is available. So not just within our project or within our whole solution, etc. It is just this file. So kind of useful if you have like a related object that's only needed by one other class, and you're like, oh, I want to keep this in the same spot, and I don't really want anything else to see it. It's like, yep, it's used internally, cool. You can put it in the same file and use it, and it doesn't have to be nested then. C# 13 added something else. Who here uses any of the old form stuff with the partial, where you end up with partial classes because there's a template that's creating them? Anybody use those? Any web forms people? Excellent. Good, good, good. That was fun times back then. I mean, wait, I'm young. No, I never used that. Lies. Some people in the room are sitting there, it's like, I forgot those even existed. I'm like, yeah, we tried. They're not totally gone. But for some reason, they're still getting new changes. Let's talk about them. So C# added this cool new thing called partial properties. And we previously had partial methods and things like that, but we can now do the same partial implementations with indexers and properties. So in this code here, you'll see that I've got a partial declared on my name, and then the implementation is down in the line below. So imagine these are in separate files. This is useful if you have any generated code. Someone's saying like, who is this for? And the answer is anybody that's working with code generators and things like that. So there are plenty of tools that you can still use today that do that kind of thing, and there's some usefulness there. Some other things I want to jump through. I'm hoping everybody saw a bunch of the code that we eliminated with top-level statements. I'm not huge on this, but it definitely exists. So when you open up new .NET projects, they tend to start with top-level statements. Unless you've specifically told it that you don't like doing this, it's going to just put your code in without any of the class structure, and you wonder who's this for. Again, I think it's for demo apps, and people argue it's for someone learning the language, but I sit there and I go, okay, that helps them with their hello world, and then they're not going to understand the structure of the rest of the code they write, so I feel like it's more for demo apps. But it's there, it exists, you're going to run into it if you haven't been in the language for a while. So I want to quickly jump through tuples because we have like 2 more things I want to get to, so we're going to go through these quickly. So we added some much better tuple, whatever you want to call it, stuff in C# a handful of versions ago. Did I say which version? I didn't say the version. I think it was like 6 or something like that. And when we added these, they added in some nice little features. So essentially, the variable, that bool success int number that we've got there, that's defining a tuple. So this is now taking those and it's creating a new object type in line at that point and saying, hey, I want an object to exist that has a success and an integer as the values here. And that is the result of my safe parse method. And so when I call it, that's what I have to return. So I can construct my tuple on that same line. So the second line of the code there, right after the little arrow, is actually a tuple declaration. It's creating one from a try parse, so that's the result that is going to come out as a Boolean value of either a success or fail from the try parse, and then we take the output parameter, that n value, and pass it as the second value in the tuple, and hey, we've moved away from having the output parameter that everybody hates and we hid it away, although I like output variables, but we'll get into that later if we talk about it. So I mentioned that was construction. That's where we were in right after the arrow. We constructed a value, we constructed that tuple, and we sent that tuple back as the result of that method. With deconstruction, we can actually take one of those tuples and break it into its parts. So if we look at the result where we use our safe parse now, that's the middle line there, you'll see that we take that result and we split it into 2 variables, number and success, and we have construction. So we didn't used to have construction or deconstruction of those, they just had a tuple type. So now, because we have this, we can do this evil. Does anyone want your team to hate you? Start doing this every time. They're gonna love you. And please don't tell them I told you to, because they will try to kill me. But you can, in one line, assign all the variables. Doesn't that look beautiful? I know, it's great. Okay, so the weird part is that we used to always have to, when doing deconstruction, so in C# 7, 8, and 9, you had to do all of your declaration, or you could assign. You could not declare and assign. Whereas now in C# 10 and forward, we can deconstruct into an already existing variable and declare a new one, whereas previously it had to be one or the other, and it's really annoying. So some of these features are, hey, they completed it. So it's actually quite nice. The tuples are great in C#, so I'm hoping everybody actually likes them now. They're decent. When they first came out, they were still garbage with names and didn't always implicitly infer the right names for things. Now they just kind of figure it out based on the name of the variable you use to assign them and things like that, or whatever name you put in there. They're pretty good. One other thing I want to talk about in this one, I'm going to go briefly on because this one's barely used by anybody, but it is a C# 13 feature, so we're going to mention it. Ref structs previously could not implement interfaces, and so now they can. And there's a nice big asterisk on that because there's a whole bunch of exceptions and weirdness with it. If you're in that case, we can talk about it, but I'm not sure how many people in here are going to run into that. But I was also having a little bit of fun with the names and other things. And I'm not going to explain the asterisk. C# 12, which is a bunch of you are going to add another feature that you're going to like. This is aliasing any type. We can now add aliases to the top of the file for pretty much anything. We couldn't do this before, so you can now just say using, declare a name, and put in a value. This can be either some other type from somewhere else in your class, which is what you could do before, or for somewhere else in your project. So if you just wanted to rename it, maybe you had a name collision, whatever, this is usually when that came up. But now you can even do it for aliasing a tuple that you created. And you just want to have that object inside this file, boom, you don't even need to declare anything, you can just kind of create this. And you might say, well, couldn't I just make some small type like a record type? You can. But if you happen to have a method, like maybe some jerk made some safe parse method that returned a tuple instead of creating his own type because he was lazy, you can give it a name and use it and still use their method that returned back a tuple, only you get a name and a type definition essentially, even though that other developer was not kind enough to give you what you wanted. So see, you can fix that other person's bad code, whoever that was. It was her. She did it. Yeah, sorry people in the other room, you don't get to see who I pointed at. Okay, so it's kind of useful because you can again just use it. I sort of explained what we were just looking at here. Global usings came out in C# 10 a few versions ago, but you've probably noticed this happened without your thinking about it. But there's a global usings, and you can just kind of set values that you want to have always in scope. So if you have specific types, you don't just have the defaults. So normally you have a bunch of defaults like systems usually included now, but you can define your own. They might be from your project where, hey, we always use this library in our code. You don't want to specify it every time. Boom, global usings, super useful. Let's see. I need to jump to something because I'm like right at time, right? Is it time? Yeah. Cool. So I want to talk about reverse indexing real fast. So they added this. So hat operator lets you go backwards, which is super nice. But specifically, I want to bring this up because, well, not because of index initialization, though that's cool too. They now let you, when you're declaring types, you can actually then also go backwards, which is more some of the other completion stuff. So carets are really useful. You just, give a little hat operator and you get to go backwards. It starts at 1, not at 0, just heads up because this comes from other languages, so they usually use negatives, and -0 doesn't make sense. Yeah, exactly. -0 doesn't really make sense, so I think that's why other languages didn't use it. And for consistency, -1 is the last item in the list, so hat 1 for us. Let's see. Then this is the thing that I wanted to make sure I jumped to, which is why I was like, hey, I'm out of time, I want to jump to this. So in C# 14, things that are in the preview right now, we don't know if we're getting any of these, but I want to mention them really quickly. We are getting extension members, we hope. So more than just the basic extension methods, we are probably getting properties and even statics. So being able to add a static to another type through an extension is going to be crazy. I don't know how that's going to break things. We're adding in a field keyword, which we'll see how well that goes. So essentially this lets us sort of define that the field exists. So if you look at this code before and after, essentially we've removed having to declare the field itself, and you can, in your property declaration, just use the field keyword and it creates the backing field for you. So if you don't want it to be exactly the normal one, but maybe you need something special to happen when you're setting the object, you can then just use the field value. You can also use it for the get. This example just uses it in the set only. Some other cool things that we're going to get is implicit conversions with spans, which before they haven't been really that great. We're finally going to get built-in explicit conversions, so you don't have to write your own. It will just convert between spans and other types. So if you want to get the performance benefits of a span, which is kind of like taking a window at memory, instead of passing around new objects, you can look just at a set that's in an existing collection. C# does a lot of moving objects around, so we can avoid that. And one thing that's probably not useful to all that many of you that I'm going to mention, but I really like, you can finally name of on a generic without specifying the specific type. So this is called an unbound generic, which just means, you haven't specified the type in it, but you can now use it for a name of, which is just a nice little, hey, why didn't you have that before, that they've added in? So I'm looking forward to it, because I've had to do those kinds of things before where you're writing some underlying code and you're like, yeah, I need to pass out the type names and stuff like that. So it's kind of nice. We've also got some additional modifiers on our lambdas. So the lambdas are getting another improvement, so I'm loving that I'm going to get to talk about those again. So essentially, we're going to be able to use output parameters and such with our lambdas, which we can't use today, as well as other things like the in keyword for parameters, out keyword for parameters, and ref passed by reference values. We can already do async and other stuff like that on those. And then if anyone's ever used the null coalescing operator in C#, we are going to get the null conditional assignment, which is going to let you, if the parent is null, assign directly. If the parent is not null, assign directly without having to in between. So that looks like this. So we basically say if customer is not null, we're going to assign into order. Whereas we didn't previously have this ability, it would yell at us if we tried to do this because the null conditional was only for gets, not for sets. So it basically disabled the setting aspect of your property when you use that. But that's going away in C# 14, assuming they don't cut those features. So there we go. Thank you. I know it's a whirlwind. I will try to make slides available, and I will stick around for questions. I know I went over time by a couple of minutes there, so I'm probably going to get yelled at. So talk to me afterwards, because I want to make space for the next person.